Thank you very much for this invitation. If that matters, for the record, my family name is Przybyl, so apparently I do have some vowels in my last name, but let's not worry about this. You can call me Piotr, Peter, whatever it makes sense for you. We are not here to learn Polish, but to learn about being multi-language and multi-paradigm programmer, right? I guess
True.
that's the
Thank you.
that's the
That's a
purpose of
great
this session.
point. So
Yeah.
I'll let you to present. See you soon.
Thanks, Sia. Welcome everyone to my talk, Go Java Developer, on this Vox Days Romania. I really hope this is the last time we have to do it remotely, that the circumstances will allow us to meet in person the next time, because I believe this is like my fourth remote talk given in Romania in general, right? So I really miss seeing human faces. Right. Shortly about me, you can reach me on using my Twitter or Telegram handle. I work as a software gardener and also as a trainer sometimes. I work for a great company called Atomic Jar, and I also, from time to time, when I have time, put some blog posts and my talks on my webpage, softwaregarden.dev. Most of my professional life is about Java, or has been about Java, I have to say. I still consider myself Java/JVM developer, but as you're going to see, things have changed recently a tiny little bit. Before we go further, safe harbor statement, caveat auditoris, make sure it's your duty, it's your responsibility to make sure I'm not telling lies. Remember, especially in these weird and unfortunate times, don't trust every talking head on the internet, including my head as well, right? And please keep in mind that this talk is not a crash course of Go, right? I'm not able to show you everything about Go in 30 minutes or so, right? So this is just about what a Java developer, being me, found intriguing in Go, found annoying in Go, can share with you, and things now, but my opinions, my thoughts can of course change in the future, right? So please don't take this presentation, let's say after 5 years, and keep like, oh, but you said this about Go or Java, right? So I think every conscious human being should evolve their opinions, right, and update them whenever appropriate. And I also do reserve for myself the right to make some mistakes in Go still, or as in Java or any other technology for that matter. Well, the thing is, I'm not quite a Java developer, like totally or absolutely, I would say, because my programming endeavor started with known object-oriented programming in C++, right? So I had managed memory, but I had, in the terms that I didn't have to use malloc, I could use new and so on, right? But I started with structural programming. Maybe that's important. I also did some PHP, like PHP 3 and 4, right, for living. I really loved programming in POC for Unix System 5, right? Without exceptions and so on. I did some stuff with Scala, and maybe like even too much. I also touched JavaScript, Python, C#, OCaml, and all other languages, right? So it's not that I'm doing only Java for living. And the story of my life recently has been like this. I got this new job at Atomic Jar, right? And I got like excited because how many times are you able to work with a Java champ and a creators and maintainers of test containers Java, right? It doesn't happen every week, I would say. So I got really excited, and then I found out that, oh my god, they're using Go, right? Not only Java. But I've taken a look and I said, oh, this looks like Sish. I see a bunch of ifs and for, so it can't be that hard, right? How hard can it be? Turns out I was wrong. It can be very hard at the beginning because I made a mistake and I tried to understand Go as if it was, a close sibling of Java, so to say. So things Go shares with Java, and this are like more or less similar to some extent, is that they work, of course. They are really powerful languages and ecosystems, so we can do pretty much everything in both of them. They use C-based keywords like if, for example, primitive types, and so on. They also support static typing. They have type inference. They are compiled languages, so they're not interpreted on runtime, right? They have garbage collectors. They give you some memory safety unless you start doing things crazy, right? And they have interfaces, and they pass bulk value. Okay, so this is not the complete list. There's probably more, and there are things which are totally different between Go and Java, and some of them are that in Go there's no virtual machine. For the record, right? There are structures, but there are no objects. There's no inheritance, therefore. The dependencies management, like where do you get the dependencies, is different. Like they don't have like Maven or Gradle, or in basically we import stuff source-wise, I would say, usually from GitHub. And Go, you have pointers, and concurrency is different, and there are no exceptions, and interfaces work in different way. I mean, we have interfaces, but like there's this interface keyword, but apart from that, they work in a somewhat different way, right? And generics were a thing that wasn't present in Go even like 2 weeks ago. Now, with the recent release published a few days ago, you are able to have generics in Go as well, but I'm not going to touch that in this very presentation. So my first pro tip, right? The pro tip for you is that this that when you search for something, search for Go, but you can also search for Golang. I mean, I don't know how one of the biggest, or maybe even the biggest search companies created a language called Go, and then it's, they have problems, or we have problems trying to find information about it, right? So instead of just going Go, many times you can try Golang. That could help. Another pro tip is it would be just better if you unlearn most of the things you know about Java and programming in Java. I mean, it would be easier to just create some vacuum, to some empty space, so we can then soak the knowledge how Go works, right? Before letting Go, just do that and make sure that your mind is empty and eager to learn. Another pro tip would be Go Playground, right? So you don't have to install anything if that matters. You can just go to this page, right? Go Playground. You can type some Go, and of course it has some limitations, like you won't be able to do some IO stuff and whatnot, right? But you can click run, and as you can see, it will work. Then you can click share, and you can send this to your friends or somebody else asking for help or something like this, right? So you can play with Go without having Go even installed on your machine. Another pro tip is that in Go, there is a thing called native executable, right? So we're not producing, I don't know, Java, ER. We just produce native executable artifacts, which are basically these are programs which have everything embedded inside, so they don't have like runtime dependencies like DLLs or jars in class path or module path or nothing like that. It's just you have this single file and that's it, right? I can show you how it works, hopefully. So let's go and switch to the terminal. Does it work? Okay, yeah. So let's go for a Go build, and let's output this as go, because why not? And as you can see, I have now a program, right, or executable, go, and when I run it, go, it runs, and it's just it, right? So it's basically this program got compiled, linked, built, and everything, and it has almost 2 megabytes of RAM, right? This is how much it uses. So this is how it works, right? There is no virtual machine, no bytecode, just native executable, and you have to create it for your operating system, for your CPU architecture. Many Go programs allow so-called cross-compilation. So for example, on Linux, I can create binaries for Windows and for Mac as well, but it's not always granted, right? So please keep it in mind. Okay, back to the slides. Yeah, this might look like a Graal, right? This is in Java world, we have a concept of Graal, so we build native images as well, things that can be just run as a single application, right? Another pro tip for you is that type inference in Go is very common. I would say, I would risk making the statement that it's more common in Go than it is in Java, but it looks like in var in Java, except there is no var. And let me show you how it works. It works like this, right? So this is, all three are equivalent. I mean, this thing, and this thing is just, you hardly ever see this. I mean, this is kind of unusual, being so super verbose. Sometimes you can see this var, and as you can see also they use very short names, very brief names, right? But most of the time inside a function, I mean, except for global variables like this, for inside a function, we just see this assignment looking like a Pascal assignment, right? But it also means please infer the type for me, right? So I'm not even using var here in this case, where the type is also inferred, but I just can do it briefly like here. And this is to increase the readability of the code, right? Another pro tip. Functions in Go can return multiple values. So in Java, in PHP, and in a lot of other languages, you can just return one thing, or sometimes the thing is void, which is no return, right? Like no value is being returned. But it turns out in Go, you can have many values, but then they all have to be consumed or ignored. Like if, for example, function returns 3 values, which is still okay-ish in some cases, I would say. You have to consume them all, or then you can ignore them, ignore some of them. And this might look like, perhaps in Java we could use record for that, right? Or the waiver library. How does it look? How does it work? I have the code. Let me show you. Yeah, like this. Everything is on GitHub, so you should be able to download it, like fetch it and run. And as you can see, this is how it works, right? So we declare that our function will have this name, like full name, and it will return 2 strings. This is not tuple, these are 2 strings, right? And then we return John and Doe. And as you can see, I have to assign it to first name and last name, right? And this is how it works. If I would skip one of them, like here, of course, then it complains here that it doesn't have ln, but also complains here that one of the values is not consumed, right? So it has to be consumed as well. Please don't forget about this, right? So there are no native or first-class citizen tuples like we have in Scala, but simply functions or methods can return many values at the same time. Okay, another pro tip. Go is very idiomatic, right? So there are a lot of idioms or customs or ways of doing things in Go. For example, this thing called OK idiom, there is done channel idiom, and there are many other idioms. And you just have to recognize them. They look like, I don't know, design patterns or something like this. And they are kind of like specific to Go many times. Here you can see example of so-called OK pattern, right? So now I have a parameter being just a user identifier, an integer, right? And it's like a super dumb repository implementation, right? So if it's 1, then I return John. If it's 2, I return Susan. For everything else, I return I don't have this value, or I don't know this value, right? And then I return anything, just literally rubbish. This could be an empty string, right? And then when we call it, you can see how it works. I assign the values as before, and I have the third one, which is the OK. And this is the OK idiom in action. So if the things were OK, it means I can safely consume the other values returned by the function. However, if that's not the case, if it's not OK, then it's like it's not okay, and I have to be prepared for this as well, right? So in this regard, as you can see, Go is pretty explicit and pretty verbose, I would say. Another pro tip is this. There are no exceptions in Go. Okay, I mean, programs in Go can panic, but panic, I would say, is more like an error in Java, right? So something you cannot recover from, something totally unexpected, I don't know, out of memory error, or basically a manifestation of badly written program, which isn't like, where stuff isn't guarded properly. And actually you don't recover from panics. The best thing you can do, actually the recommended way, is like, okay, we can recover to just snapshot some things, I don't know, parameters, execution environment, something like this, and then we go belly up after, like, let's say logging it or sending to a remote system anyway, right? So we don't have the concept of throwing something and capturing something and then reasoning. Errors have to be explicit, just as we saw the OK in the previous example, right? And errors, by the idiomatic way, returned as the last value again. And I would say this is like opposite to the either used in Java or Scala, right? So the right value is the right value and the error is the left, right? Because the thing is just that is right. So in Go, errors are on the right or rightmost side of the returned values. And this is how it works. You see, it's not rocket science. And now instead of like Boolean, I have an error, right? And if, let's say, I think that this UID is basically incorrect because it's outside of my domain, I can say incorrect UID, then it's the same as here. And please note, then I'm returning nil as like no error, basically. And here I can return no such user, right? So I can differentiate situations when one thing happens and another thing happens, right? And then as you can see, I'm selecting, maybe you could try to run this, right? This is pro tip 7. So let me open, yeah, let's try to run it and let's see what happens. Okay. And you can see it must have been 1 because we had John Doe. Let's run again. And now we have 0 because it's incorrect UID, right? So how the checking works. Again, instead now of okay, we have the error, and if the error is nil, like means there's no error, then we can proceed as usual, do stuff as usual, because things work as expected. Else we have to, handle stuff. So in this very example, I'm just saying that this user is, for example, unknown or something else, right? And then I show the error to the user. I mean, how you react on an error is like, it's your business, basically. You have to know that. It's just like what you do when you catch an exception. Pretty much the same way, I would say. Another pro tip when you try to learn Go, being Java developer, is that there are no objects and therefore there's no inheritance in Go as such, right? I mean, there's no object-oriented programming or object-oriented paradigm. There is no implements in Go, right? Yet the interfaces might be implemented in an implicit way. And let me show it. Maybe in code it would be easier. So, as you can see, nothing changed here in the signature. I'm still supposed to return an error. It's just in this case when it's 0, I wanted to return my own custom error, being incorrect UID. So I created this type, and this type is basically a structure which has one integer, the UID, which is incorrect, right? And then how does Go know, the compiler and so on? Because as you can see, it compiles and works. Let me demonstrate to you that it actually works. How does the compiler know that this thing is an error if I didn't use like implements error or whatnot, right? We have to check what the error actually is in a Go library. So as you can see, error is an interface which is supposed to have one method, error method, which takes nothing and returns a string, right? For that matter. And as you can see, I have provided this this method working on this structure here, right? So this is the method. It's an error method that takes nothing and returns string, and I just basically return this. And because of this, it's like implementation by duck typing, only check on the compile time, right? So then, as you can see, if I have like basically removed this, right, or even like let's call it error by like misspell it, then it doesn't work because incorrect UID is no longer an error according to the compiler. For it to work, it has to implement the methods that are expected of an interface of error. And beside that, it's pretty much the same. Oh, it's like here we can see something similar to instance of. Only please keep in mind that we use this errors.as or .is in Go exclusively, I would say, for errors. We don't rely on types like with instance of or pattern matching like we do in Java, especially in modern versions of Java when there's since Java 17 we have this pattern matching, right, based on types. Okay, so another pro tip. Perhaps you need to inherit via composition. I mean, there's this rumor or saying or this common belief that inheritance is always bad, right, and the composition is always good. I don't agree. Like in proper OOP languages, there are places and situations with OOP is the thing that you should use, the concept, the paradigm, or whatever we call it, because one thing is another thing is of type of that thing, right? It's just we don't have inheritance in Go, and sometimes you can. I mean, that was one of the biggest things that shocked me actually in Go. First, let's make sure that this runs. I mean, that you can like inherit the methods, but you don't have objects inheritance and so on, and this happens solely by the composition. So what do we have here? We have a type of swimmer, right? This is a structure, and we have this style, and then we have a method on this. I mean, when I put something like this, instead of just saying swim, I mean, this would be normal function, right? And when I use some, I don't know how it's called, receiver, it's called receiver, right? This thing, then it means like, acts like a method. So I can go and call it with this dot notation, right? Instead of sending the swimmer as a first parameter. So this is like method by Go means, right? And the swimmer can swim, as you can see in given style. And similar thing applies to runner. So I have swimmer and runner, and they virtually they're like very similar, right, in the concept. And then I have a hippo, which is swimmer and runner, and I don't include it as the like with the name of the type. I just include the type. Then it means I can create a new hippo. This is the hippo, right? And you can see nice type inference, right? And this is pretty obvious, right? This thing is obvious. So I have a hippo. Inside the hippo, I have a swimmer. This is the swimmer I created. And like, think of it that this is the Go's way of making a new or calling constructor, although it's not a constructor, technically speaking. So I pass swimmer and run it to hippo. And then it's obvious I can run this and it can run this, right? So we can see swimming slow and swimming fast. But I can also do this, right? So I can omit this, like, let's say, encapsulated types or structs, right? And then I can basically call the methods like this, as if they were inherited in Java, I would say, right? So this is the way, you see, we compose that the hippo can be of swimmer and runner, and of course I could add like other things. I could go like, say, weight, right, in being an integer, for example. I mean, it's stupid type for something that's not discrete, but let's forget about it. And here I could create, let's say that it weighs, I don't know, like let's say 10 tons, right? I don't know if it's a good weight for a hippo or not, but as you can see, I can add other stuff as well. So it's not limited only to this thing. So it's, I don't know, like like some types algebra or something like this. Okay. Another pro tip is this. Methods and functions can't be overloaded in Go. And this may shock a lot of people, and it also shocked me. Well, maybe like surprised. And at the beginning, I was thinking it was like a bad thing, right? So in Java, we like used to having the same method name. It's just different set of parameters, or different list of parameters for that matter, right? And then we call that these methods are overloaded, right? And the compiler knows which one to invoke, and so on and so on. In Go, there is no such concept. I cannot name this method exactly like do, because this name is already reserved. Like, there is another method declared with this name on this something structure, so I can't basically do it. I mean, another method. Therefore, for each set of parameters, I have to figure out a new name. Some would say that this is like too verbose, but on the other hand, this is very nice for people who don't do a lot of programming, right? And they are not surprised that, you know, by some weird concepts that they're like overloading and so on. Everything is pretty much explicit. When you see a name, you can be sure that this is this given function or method, right? It can surprise you. Another pro tip, access modifiers. I'm sorry, they don't exist in Go. So how blocking the access actually works? Well, it's actually quite simple convention, maybe idiom again. So it works like this. We have one package and we have another package, right? And everything that starts with uppercase letter is visible from the other packages. It's like, let's say, exported, or it would have been public in Java, right? Everything that doesn't start with the uppercase character or rune, as one could say in Go, then it means that it's not exported and therefore it's not visible. Therefore, I cannot uncomment this because the compiler would complain that this won't work, right? So this function is visible. this global variable is visible, but this one is not visible. We could say it's package private, so to say, right? Because it's at the level of package. This is how it's declared here. Right, so there are no public, protected, default, or private, or even like more sophisticated access modifiers. I don't know, like private this in Scala, right? There's just convention, and you follow it by using proper case, and that's it. Another pro tip: Go's arrays aren't like Java's, and this was also like a big hit. And actually, this was the moment when I thought I understood what's going on in Java actually better. Arrays are values, and we'll get to that, right? And maybe this like can help you as well understand what's the goal, or one of the goals, or like maybe for me it just looks like things that we're going to earn thanks to Valhalla. So let me show you one like kind of like more sophisticated examples, I would say. So we have this, how to declare an array in Go. So I could say explicitly, this array is going to have 3 elements. It's going to be an array of strings, and I provide these elements, for example, right? Or I don't have to provide them up front. It doesn't really matter here, I would say, right? It should still work. Oh, sorry, wrong key. Then I can also say like I'm going to use this literal, and please compile and figure out the number of the arguments for me as well, right? Let's run this code. Let's see how it works. This is how it works, my friends, right? And this is pretty expected. I mean, you expect ABC printed here, and this is the case. You expect DEF, and this is the case. And then what we do is we do this, okay? We create another array, and we assign the value of A3, right? And this is different from Java, right? In this copy, we replace the first element. We say it's DD, right? And as you can see, it's not changed in the original. Means the whole thing got copied. Means it's a value, right? And for the record, it's not going to work. What the compiler is going to say, we can't assign a value which is an array of 4 elements to a variable which should hold only variables of 3 elements. So it turns out that in Go, the size of the array is also the part of the type, right? And I could say, why so much hassle? Why is it so important, right? I mean, that the arrays are values. Well, it can be useful in many situations. For example, you need to read like a constant number of bytes. Let's say you have like a given maximum size of package or file, or I don't know, file header, things like that. But there's more important thing, right? So the fact that arrays in Go are values, it means that they behave like primitive types, right? Like integer, for example, or Boolean in Java. And that means that the compiler can create the bytecode so that the value will be stored not in the heap, but it will be stored on the stack. And the stack is better for such things because you have these calls, right? We have this basic method call or function call, and it gets the stack, and then there's another call and another call, and after this call is finished, we don't have to like do sophisticated mark and sweep, or I don't know, we don't have to use this concurrently compacting garbage collectors or whatnot, because we just know this part of the stack has to go away, bye, and then we can do another call of the method. Therefore, using stack for allocating is more efficient than using heap, right? And this is why it makes sense for the arrays to be actually values. Okay, and this is like shows why, or what can we go perhaps thanks to Valhalla in Java, that more and more things will become these value objects. They can be treated like primitive types, at least in Java, right? Meaning they have like fixed size and whatnot, and they therefore can be, and they are immutable, perhaps, which is not the case here, as we saw, but that there's more efficiency, or let's say less work for the garbage collector to perform, right? Yeah, this is the example I've shown you. Another pro tip is that slices are wrappers around pointers and arrays, right? So They're not relying on the size, and they can append friendly. So we couldn't append to an array before, right? But thing is, it might be tricky sometimes. Let me show you slices, like the demo of slices, because this is like one thing that might surprise you. In Go, there are, at least in the standard library, there are no sophisticated data structures. Like we have a whole set, like a whole zoo of lists, sets, I don't know, maps, and whatnot, right? And this is not the case in Go. So in Go, in like vanilla Go, you have arrays, you have slices, you have maps, and that's pretty much it, I would say. So of course there are libraries with like mimicking our linked list, or I don't know, tree hash set or whatever, right? It's just they're not in the standard library. Okay, so we have the slice. As you can see, the slice differs because we don't provide or even tell the compiler to infer the size, right? So when we print the slice, it works it works the same here and works the same here. And how would the replacing work, right? As you can see, when I replace the first thing, then it replaces also in the original. So that is one thing that is different, right? And the other thing is that this behavior changes after we append to the copy. Then the copy, because of the way that it's created, then the pointer of the copy no longer points to the original array, but points to a newly created array. Therefore, replacing elements then will create, as you can see, discrepancy. Of course the appending worked, but it meant that the slice reached its size, and then the capacity reached the length, and we had to, or the compiler had to arrange the stuff that there will be a new array created, and so on and so on. Meaning, like, bottom line, I can understand that this example like overwhelmed you. Okay, just please make sure that the append on slices kind of like changes or like throws the table of how we are used to working with like lists or sets in Java. Okay, please remember that. So for slice to be used properly, you need to understand how pointers and arrays work in the first place. Okay, another pro tip: use GoFMT. Oh gosh, I love GoFMT. Let me show you another, like, how it works. Let's say this is I can do something like this, right? And as you can see, these aren't needed in Go. So what do I do? Like, and we have this constant battles in like in teams or organizations, like which style of the formatting is the right style of the formatting. Shall we use 2 spaces, 4 spaces, 3.5? I don't know. In Go, they don't have such problem. They use just this. They go FMT, which stands for format, and I'm just telling format everything in the source 3, kaboom, right? And it got formatted. And as you can see, I don't have this, right? And if I change, I don't know, added spaces or add spaces here and whatnot, right? And even here, IntelliJ, I told my IntelliJ or Goland to format it for me properly, right? So as you can see, there is one style of formatting, and that's it. So they have no battles like, differently formatted source code and so on. Highly recommend. Like in Java, we could use Prettier, right? With Spotless, it will work the same way. I highly recommend that. Okay, another pro tip: threads might be too heavy, and they're not flexible sometimes, right? For example, on threads operated by an operating system, we can have dynamic stacks, or they can change during runtime or whatnot. And therefore, we might need also something lighter, something more flexible, something easy to switch. So we can use Go routines in Go, which aren't threads, right? And they aren't even lightweight threads. And as we all know, we're going to have, I hope so, we're going to have Loom in Java, hopefully sooner than later, which is based roughly around the same idea, that the threads, first we had processes turned out to be too heavy, so we switched, or I don't know, JVM switched to threads, and now we're reaching the stage where threads are too heavy again, so there are like coroutines, Go routines, and whatnot, and we're going to have Project Loom in Java, also bringing us something like, I don't know, green threads, lightweight threads, or like something, not tied one-to-one to OS thread. I don't know what's the name this week. Sorry. The down calls to C are quite simple, and this resembles like Panama, right? And it's maybe even simpler. Let me just show one thing that's going to be a final source code demo, I hope. So we basically are going to, as you can see, it's a piece of C, and it's not very nice and so on. I mean, it's colored back because I'm using IDE. If we were watching this in like a notepad or something, it wouldn't have been formatted properly or colored or whatnot, because this is just a part of the comment. As you can see, this is how C can be called from Go, right? And I import this upper C package, which means I can then wrap my string, my Go string, into the C string, right, type, and then I can call the function greet from C and pass the greeting, and let's see what will it do. Yeah, it just worked as expected. It also like showed us the thread ID using the system call and so on. As you can see, because I started two Go routines, right? So I started one Go routine which says hi and the other one which says hello. Both are calling this C method, right? And this method is also showing us not only the greeting from, but also from which thread using the thread ID. So as you can see, calling C from Go is really no-brainer, right? And I really hope we will get there with Panama as well. Also using, marrying C and languages with managed memory is not easy, because in C the layout of the memory doesn't change, and in Java and Go we have garbage collector, and garbage collector can, compact memory, can evict stuff from one area of the memory and put it into another, which means if we have like the opposite calls, like stuff from C calls us something in Java or in Go, we have to handle that. That's not that simple, right? And it's still possible. And I really hope that in Java, thanks to Panama, we'll be also able to call C as easily as in Go these days. Yeah, that was this example. If you got hungry, I sincerely hope you guys got hungry and you would like to learn more about Go, then I suggest reading Learning Go by John Botner, or reading a series of articles or presentations by Dave Cheney, Practical Go. There's a thing called Go by example, like how do you do stuff in Go by give an example, basically. And there's also a very nice YouTube channel just for funk, as you can see, because there is no fun but funk keyword in Go. So I recommend this. And my takeaways for you. So first, unlearn, then learn, then test. I mean, when you write a piece of code, please test it, because the assumptions that you have imprinted in yourself, like after years of programming in total different language, can hit you, and it can hit you really hard and really bad. So like test what you've written during this learning, and this will also allow growing your brain, right? Experiment and have lots of fun with these experiments. I mean, Go is very nice for experiments, and enjoy this boring, because this lack of this overloading, right, and other stuff makes it like it's actually very boring. It seems to be boring language, but there is a purpose of it. If it's boring, it's also easy for newcomers, right? So we can like include easier new members, from out there, basically into our team. And it's also, therefore, it's more machine friendly, like I've shown you with this example of arrays and so on, right? So IO or networking in Go is like much more machine friendly than in other languages, I would say, at least the ones I've seen. Appreciate both Go and appreciate Java as well, right? Both languages and other languages too. They are no bad languages. They are just languages selected badly or in appropriate way for the task that they're supposed to handle. Also, I ask you to provide feedback. I mean, we're not seeing each other face to face, so you're not able to give me some paper, right? But you can fill this internet poll if you'd like to. If this is like anonymous poll, I don't know who you are, don't collect any data, it just answers, you can just answer a few simple questions, right? What you like, what you didn't like, and so on. Or, yeah, I don't know, vote for the talk and let me know how it was, right? This was it for today. I hope you'll enjoy not only LC racing, but also using like this racing language and paradigm and whatnot. And the slides are here for you, and so is the code and everything else. Thank you very much for learning Go with me.
Thank you, Piotr. You're a bit over time, but we have 2 questions for you, so I would like to ask them.
Okay.
So first one is, where can I find all the Golang idioms or typical folder structures? Is there something like PEP8, official style guide for Python?
There was this old I mean, I don't consider myself as a Go expert, so please take my answer with a grain of salt. Okay. There used to be this old style. This new style is that the Go is using this module. So as you can see here in my project, I also have this Go mode, and then usually you have like packages here, and then the packages like directories for packages, and they get included and so on. So this is the style I'm used to, and also I would suggest that Go, it's not impossible to create like a huge systems or behemoths in Go, but I would say think this microservice way, right? So if you're afraid of rewriting something, then it's no longer a microservice, and therefore maybe at least initially Go might not be the best choice for you.
Oh, thank you. And their last question is, for which types of applications would you use Java, and for which would you use Golang?
Oh, that's a tough one. I don't know if I can answer it. So what I'm working on currently is on a client-side application. I mean, the thing that's running on developers' machines, right? Because it turns out that it's easier to create this native application in Go than in Java, and to integrate it with various, how things behave and look and work, right? Of course, Go is very well known for using a lot of servers or like microservices, right? Because this is really shines. But you can also write like a single usage scripts in Go as well. So instead of building, as I will show you, you can also go for, and if I'm not mistaken, you can go for Go run and then just go. Let's try if it works. I didn't try it before. Yeah, it worked. So as you can see, you can even run a single use script. So I would say you can do pretty much everything with Go.
Thank you.